Okay. Today we're going to talk about F# type providers. Just before we start, the quick show of hands who has done some F# programming before? Okay. And who's a .NET developer? Okay, that's a good balance. Especially when we get to the code, I'll try to keep it simple so that everyone understands. If you have come from a .NET world to F#, you want to know what type providers are. Basically, they provide static typing on some dynamic data sources, something like what you would do on .NET environment when you generate types based on a WSDL or something like that, or when you have a dynamic static library to work with a web service or a remote service call. But it's a bit different in a way that it generates those types and properties and methods at runtime instead of compile time. So the benefits of that is obviously statically typed, and you have a way of writing your own type providers so that you have all those flexibilities so that you can have that experience in a way that you want. We'll see in the code shortly. And it is kind of cross-platform and cross-language so that you can run it on Linux environment using Xamarin or the way you run F# on Linux or Unix. As well as you could expose those types in a C# program if you want. So the question is, where do you even use type providers? The simple usage would be the data access. So if you have a data source that you need to query, like the way that you would use an ORM, you could use type providers. There are type providers that you can use to access databases or data files like CSVs, XMLs, and things like that. But other than that, there are a few other scenarios that you would want to use type providers, like when you want to use a enterprise or internet data service like Freebase or World Bank data services. Especially in those cases, the model that you interface with is so interconnected that basically you can't generate types either manually or using it code generated because the types are interconnected, and it would be probably not possible to do that. So there are quite a few type providers out there. The basic ones would be XML or JSON or CSV, or some other type providers are for WSDLs or OData or EDMX. Those are kind of like the way that you use it on C#, like the way you generate types based on a WSDL. It would kind of do the same thing but on the runtime for you. But there are other more advanced scenarios where you interface R, which is a language to work with data, which the data scientists mostly use, or when you want to interface with Freebase or World Bank, as I said, or Hadoop or Hive data sources. So the question is, do you even need to create a data provider for yourself? You probably don't. There are quite a few out there that you can use, and if your company you work for, or your enterprise has a built-in data source that you want to interface with, you might want to generate your own type provider. But other than that, if it's a data source out there, probably don't need to do that. So the questions that you need to ask before you see if you need to create a type provider or not is the scenario that it best fits with, which is if it's a data source that has a schema, so you need to have a schema of some sort. You need to have a mapping of that schema and your types in .NET, so how would that mapping would do? And the other thing is that it's probably worthwhile if you do that if the schema changes regularly. So if it's a fixed schema, or if it doesn't change that much, it wouldn't be worthwhile. And the other thing I mentioned is that if the schema is too interconnected, you probably would want to go with the type provider. How would you consume that type provider in C#? To answer that, you need to know the type of type providers out there. So basically, there are two types. One is generative type providers, as I mentioned, like the WSDL or CSV, which use a tool under the hood like IL-generate or things like that to generate a code, pretty much like you would use a code generator tool in C# to generate code based on a WSDL. The other, which is the erasing type provider, which is a kind of a different thing, uses F# quotation expressions to generate the code. This one, because it doesn't generate the actual code, actual types, it performs much better if your schema is interconnected or is large. Whereas the other one is kind of like for the smaller schemas. The other difference is that when you use the generative type provider, you can expose those because it generates the types. It doesn't generate the wrapper around the types. You can directly expose them in C#. Whereas erasing the type providers doesn't generate the actual types, so that you have a bit of a harder problem to expose that in C#. The bad thing is, or rather bad thing, is that the new type providers are generated using erasing type providers. So you probably having a bit of a problem exposing them in C#. So let's see the code, and let's see how we use the type providers. There is an F# data library, which you can add a reference to through NuGet. That would be this one, which would give you some of the type providers like the CSV, XML, JSON, and Freebase and World Bank. There are some other type providers out there. There are quite a few of them actually. As an example, the other one, which is SQL Provider, is another library, and it's not even released yet, but you can have a play with it. And there are some others officially from Microsoft and some other libraries. So let's start with the CSV Type Provider. For those of you who are not familiar with F# that much, I've tried to keep the examples close to C# so you don't get lost.
Increase it.
Yeah, sure. Hello? So the way it works is that first you open up a namespace, which is F# data coming from that library. And then you can declare a CSV provider, which is that type provider. And it takes a bit of a configuration here. And the only configuration it needs here is a reference to some sort of a CSV, which doesn't have to be the actual CSV file that you need to work with, but should have the schema of the CSV file. So as much as it's an empty CSV file with the same schema that you'll be working with, it should be fine. But for this example, I kept them the same. Then there's a print function that would open that file, read the file, and then read the data files and then pass them through a sequence, pipeline it through the sequence. Sequence, if you're coming from a C# word, is like an IEnumerable. And then you have those functions on top of the sequence module, which is map, and then filter, which is like a var clause, and then toArray, and which is all available in C# as well. So we basically get a list of rows, and then we iterate over them, and you can filter them based on some criteria, and then convert them to an array, and then from the array we can iterate over them and then print some of the properties of that CSV file. Yeah, I'll show you the CSV file in a second. Yeah, if you have let me open the CSV file. So the CSV file is here, and here's where it gets interesting. So if you have a look at the top, the first row is basically the schema. And as you can see, it has the column names, first underscore name, last underscore name, and things like that. And in the code, we haven't done any kind of mapping to that CSV file, but the code, as you can see, understands those properties. So if I go row dot, it will generate a list for me, and IntelliSense and everything works fine, and it's statically typed. I can access anything like the country or whatever. So you can see everything's done at runtime, but the interesting part is that if I change this first name to something else, like first name 2, it won't compile anymore, because everything is generating at runtime. It understands that the schema has changed. It recompiles everything and generates the types, and understands the first name is not there anymore. And when I use the IntelliSense, it uses the new name. And that's basically the beauty of the type providers. It gives you the power that whenever things change on the schema, the application automatically won't compile, so that you know what's broken, versus the C# approach to say, let's say, web services. When you change something on the other side and regenerate, sometimes you get the compilation error, sometimes you don't, and at runtime you discover that, yeah, this is changed and this property doesn't match anymore, so you need to fix it. So yeah, you get this kind of IntelliSense. The way that the type providers work is mostly like this, that you need to use a type provider, give it a schema, and then give it the actual data, and then work with that data. So the next example, if you want to run this, I have a program FS here, so I could just uncomment this, which will just call that function, just to make sure it does work. Just making a call to the print function, and the output comes out into the console, and we're filtering the CSV file to print just one entry. The second example is the JSON type provider. It's yeah. Yeah.
Are they, we all assume it's a string type, or can it be an int or a different date type?
Yeah. If we go back to the example, so you can see that it generates a type, and then you can decide what the actual type is, because everything in a CSV file is a string at the end of the day. You could convert it to a GUID or an integer or whatever the actual type is, and then it will do the conversion for you if you use the right type.
But most of the type providers will infer that type from the sample that you give them.
Yeah. So in a CSV file, if you have an actual number, it will generate an integer for you. Or if you have decimal points, it will generate the decimal for you.
And if you have missing data, then you will infer it as a nullable.
Yeah.
I think with CSV it gives you an option. It turns it into an option type.
Option type, sorry.
Yeah. No.
And the other thing is that not all CSV files are the same. Some of them are comma delimited. Some of them are using other tabs or semicolons. And you can configure that up here when you give it a reference to the CSV file. You could say use tabs instead of spaces or things like that. So you have some configuration you can use. The other one is the JSON type provider, which looks pretty much the same, but the only thing that is different is that you could give it the reference to the schema in line. You don't have to do that through the JSON file. You can actually give it give a reference to the schema over the web. So you could point it to an HTTP endpoint, which is exposed as a JSON, and that would infer the schema, and then you can work with the actual endpoint and get the data using the generated types. The only thing that I wanted to show here is that the JSON provider is actually kind of intelligent, whereas if you have worked with JSON, you know that there are different naming conventions. So some name this first underscore name, some name them first name like this. Oh, sorry. Let me bump up the font size. So yeah, as you can see, the property name in the JSON schema is first underscore name, but the actual JSON type, the actual property type is uppercase F and uppercase N. And it would generate still the same thing if we name it like that. So it won't matter. So it's intelligent enough to know how it should generate the actual property or actual types for you. It doesn't have to directly map one-to-one to the actual schema.
And would you get a runtime error if the data you're providing doesn't match the schema? And if you were to run that right now, will you get a runtime error?
It won't compile if... No. Right now, it does compile.
What about a runtime error? Will it give you that, or will it just...
Yeah, you still could point it to a wrong schema, and then it won't match the data, and you get an exception. Yeah. Again, let's see this one at runtime. So the actual function would just parse that bit of JSON. So it will parse that with parse the actual JSON that has the data, not just the schema, and then print it on the screen.
So it can load the data from a static location, the schema from a static location and the data from a dynamic location.
Yeah, you can load them from wherever you want. The next one, which probably is a bit more interesting, is where you work with an actual database. So I have a AdventureWorks, Microsoft AdventureWorks database on my machine. I just create a new SQL data provider. All I give it is a connection string, nothing else. And from that, it can infer a lot of things. So I have a print function again. The way I can work with that SQL Type Provider is that there's something called the data context. I get a reference to the data context, and from there, I can see everything basically that's in the database. So if I go dot, I can see the schema, the schemas that are in the database, as well as the table names. And from the table names, I can go over the columns. So as an example, the person table in the person schema would have all these columns. It also has some methods that I can call, like delete and some other. No, this is not Entity Framework. There is another one called EDMX Type Provider, which uses the EDMX schema to generate something similar to what you have in Entity Framework. The interesting thing is that it also generates the references to other tables. So all the relations are also generated as a kind of a navigation property. So yeah, you can iterate over the database, and what you can also do is you can go context this table there's something called individuals, which would give you access to individual rows. And then you can go individuals row 1, and then you get access to row number 1 in that table. So it gives you flexibility up to that point. Sorry? Yeah. Yeah. The next one is a Freebase type provider. If you have heard of Freebase data source, it's an open data source over the internet. You could query it for lots of things, like from the media world to the name of the movies, or everything you can imagine is just probably there. The way it works is that if the data provider will make an HTTP call over the web to access the schema as well as the data. Again, to use this, you need to get a reference to the data context from the Freebase data provider. And you can do it in a couple of ways, like we saw that in previous example, or you could run a query expression, which is kind of like a link query, really. It's written just a bit differently, but it's kind of like a link query. So you can go Freebase this collection, and then drill down to what you're interested in, and then apply some criteria, apply some ordering, and whatever you want. You can pretty much do anything, and then use the available free data that's available on the internet. If you want to have a look, it contains pretty much anything you can imagine, from sports, society, products and services, time and space, transportation. Let's go with, let's say, just a bit more arts and entertainment. You could go into books, films, games, media, etc. In this example, I've gone with I've gone through science and technology into chemistry, into chemical elements, to write down the atomic number and name of symbols in the periodic table. So the way it works is that I generate a query on the elements that has an atomic number, and then order them by number, and then convert that to a list, and then iterate over that elements, and then print it on the screen. And just to make sure it does work, this one. And apparently it does work. The other way to do this is like the previous example. Instead of using a query expression, you could just go fb.arts and entertainment .books .poems, and then pipeline it through the pipeline operator, convert it to a list, and then iterate over them, and then access the properties like the author, the article, also known as the copyright and description, and etc. Just undo this to make sure it compiles. The last type provider I'm going to go through today is kind of similar, which is the World Bank type provider. What did I do wrong? Okay. It is kind of similar. I'll show a couple of more techniques to work with this kind of data sources. Here again, you go through World Bank data type provider, get a reference to the data context, and then basically, the World Bank data provider provides information about governments and countries. It is similar to Freebase, but it's different category maybe. So I go over the list of countries, and I pipeline it through the find method of the sequence module, which is kind of applying a criteria, which is here, where name equals something I pass in as a parameter to this function. And then indicators are the values underneath that country, and I'm going over the indicators, which are, if you want to have a look, has quite a few. If you have a look at the scroll bars, you can see how much detail it is. So here we go over school enrollments percentage growth. And then we call that in the print function down below, we call that function and get the maximum of that value. So if you have a look, the value is returned by this get data. Where is it?
Get max by is returning a tuple?
Yeah, the indicator return is a tuple, which has the year and the actual value. So we use FSD and SND, which is first and second, to access that the tuple elements. If we try to run this one, oops. You can pass in any country that you want. We'll grab the data for that country, and then we'll give you the year and the actual value. The World Bank data provider is designed in a way that it works with another library, which is down here, named f#.charting, so that you could just grab the data, put it in a chart, and then see how the result looks like. So I'm just calling the getData function and pipeline it to the chart.line, and you can have different type of charts if you want, but I'm here using the line type chart, and then call the show chart method on that library, which would give me this one. So it will grab all the information on that indicator for that country, and then draws that as a chart on a window. But you can also do a bit more interesting stuff. So you could have, as you can see, it has types per pretty much all the countries. So you can just go by country, or have a list of countries like this one, and then for each country get some indicator, and then feed that through the chart.line function, and then use another function that is chart combine, that will combine all the lines in one chart and then show that. So we're going to show that that indicator for all those countries, which would look something like this one. So pretty simple. You could quickly put it together and show some charts on the screen, and you can compose it with also other libraries like the chart library here. The last one is some other way of using this type provider. So as I said, the type provider has a bit of a configuration, and you could configure that here like this, saying asynchronous true, So it would generate the asynchronous version of that type provider. And what it does, it would, like if you come from the C# world, you know that you can run that, because it's a call to an HTTP endpoint, it could take time, so you can run them asynchronously. And the way it's done in F# is just marking that as to generate that type asynchronously, and then once you want to query the data, you could do it like this. Once you have the actual query here, you could pipe it into async parallel, and then async run synchronously, which would...
Isn't that redundant?
It's run synchronously because it's a wait. It
Yeah.
would be like, okay, stop here, do something.
So yeah, it will run all those indicators for all those countries, and then do an await, and then pass that to the chart line, and then combine them together, and then show that on the screen. And it will look pretty much like the previous example, but it's done asynchronously. And the only thing that you could see is that once you declare that type provider to be asynchronous, you just need to pipeline it into async parallel and async, if you want, async run synchronously. That's, I think, all the examples I have for tonight. If you have any questions.
The actual type instance are created. Are there something like dynamic proxy that's...
No, there's no dynamic proxy, but as I said, there are two types of type providers. One is erasing type providers, that which is,
What does that mean? Like,
it doesn't generate the actual types. It would generate kind of wrappers around the actual types. And it's all done at compile time. Even yeah, at compile time, it would generate something for you. It's not the actual type. So
Type instantiation happens at compile time, not runtime.
yeah, everything is done at compile time.
Is it possible to use them in C# or...
So yeah, if it's a generative type, like the one we didn't see, we saw a couple like the CSV, or if it's a WSDL based type provider, it is a generative type, and you can expose the, because it generates the actual type, it doesn't generate a wrapper around the types that you will be using at runtime. It generates the types that are compatible with C#, so you could, it's like generating proxies for a WSDL.
So it's more feature of Visual Studio to F#
No. It taps into the IntelliSense. It generates the types so that by the time the IntelliSense kicks in, the types are there. Yeah. As I said, you could use this in Linux. As long as F# works, this works. It's not a feature of Visual Studio.
Can you show how to write your own app?
Yeah, that probably would be another talk if you're interested in, but because it's a bit complex, but you could do it. Basically, there's an interface that you need to implement, and they have provided a base type, because that interface could get a bit complex. They have provided a base type, so you can extend that.
Which is easier, writing a link provider or a type
It's very much easier to write the type provider. You can compare it to writing link providers. It's very easier, much easier. We could do this in another talk if you're interested in.
Can I write my own program?
I don't mind. Sorry?
Can I write my own program?
Yeah, you can. Yeah. That's what the other question was. Yeah, you could just implement it. Technically, you could just implement an interface and do whatever type generation that you want.
There are type providers. He showed one for R, the R language, and there is one that they are building for Python. So you could access Python types from F# by using type provider. So if you think about the fact that it's reading a source of data and making types for you is quite powerful.
If you're interested in seeing what our opportunities are out there, you could have a look at a couple of examples here. So F# data is the library I mostly use. There's also another kind of project called FunScript, which would also use the type providers. It would convert from F# to JavaScript. So it also uses type providers. And there's also the World Bank provider that we just saw. And there are examples on how to implement your own type providers on MSDN if you're interested in doing that. Any other questions? No? Thanks.